My name is Bookish, and today is June 12th, 2026, Friday to be precise. This is Chem 122, Organic Chemistry, second semester Chemo. I will be playing with the man we call Inductive Effect. Follow me. If I write something like this is hydrogen combined with another atom of hydrogen to form a molecule of hydrogen, which you normally write like this. So in a hydrogen molecule, we have two identical atoms that have come together to make up this molecule. How do you form that hydrogen molecule? This hydrogen will provide one electron. The other atom of hydrogen will provide one electron. Now those two electrons will be shared, will form a binding force between the two atoms to form the molecule. Now the first thing that you have to bear in mind is that anywhere you see a covalent bond, there is a covalent bond existing between the two atoms that make up this hydrogen. Wherever you see a covalent bond, know that there are two electrons that have been shared to form that bond. Anywhere you see a covalent bond, this is a covalent bond. Two electrons are present here. Now, remember we said that these two electrons have to be shared before you can form this covalent bond. And now you notice that the atoms we have here are identical. So they have the same electronegative value. They have the same power to attract electrons. So when the electrons are being shared between the two of them, those electrons will be shared equally. That means that the electron density will be distributed equally between the two atoms that make up this molecule. Reason, the atoms are identical and they have the same electronegative value. Is that okay? And that is why a molecule like this is described as non-polar. It is not polarized. It doesn't have separation of charges. It's a non-polar molecule. However, if you look at somebody like this, let's say you have HCl, hydrogen chloride. Again, hydrogen brought one electron. Chlorine brought one electron. The two atoms shared the electrons to form this covalent bond here. Remember, we agreed that anywhere you see a covalent bond, there are two electrons that have been shared to form that bond. So every covalent bond is characterized by two electrons inside that bond. But you notice that in our first semester, we said something. When you're moving across the period in the periodic table, electronegativity increases, which is the power to attract electrons. Hydrogen can be placed in group 1. I'm sure you're aware of that. And then chlorine is a member of group 7. So if I'm moving across the period in the periodic table, I'm supposed to see hydrogen before I will see chlorine. So chlorine is a member of group 7. In fact, a halogen. Halogens are expected to have the highest electronegative value. Power to attract electrons. That's electronegativity. Now, hydrogen is poorly electronegative. It doesn't have enough power to attract electrons. Chlorine is a highly electronegative with the very high power to attract electrons. So when somebody who is poorly electronegative with a small power to attract electrons is sharing electrons with somebody who is highly electronegative, what do you expect? Excuse me. Hydrogen is poorly electronegative. But chlorine is highly electronegative. So it means that when hydrogen and chlorine share electrons to form this bond, chlorine is going to receive a fair share of those electrons. The electron density here will be shifted towards chlorine, making it to develop a partial negative character. Remember that whenever an atom gains an electron, it becomes negatively charged. But when an atom loses an electron, it becomes positively charged. Now, chlorine is like shifting the electron density here towards itself, which is like gaining electrons. But because it doesn't gain the electrons outrightly, it's just a mere shift of electron density towards itself. So it will develop a negative charge, partial negative charge, a partial negative character, leaving hydrogen here with a partial positive character. So you see that in a compound like this, we have internally separation of charges, negative and positive. And that is why this compound is said to be polar. It's a polar compound. It's polarized. It is characterized by separation of charges. Why? Because chlorine is more electronegative than hydrogen. So when they share electrons, chlorine will receive a fair share of that electron, shifting the electron density towards itself to develop a partial negative character, leaving hydrogen with a partial positive character. Now, let's bring it to the course proper, Chem 122, which is organic chemo. Follow me. We're going to somewhere. I need 100% understanding. If I have somebody like this, take a look at this person. Watch me, we are going to somewhere. This is a chloro group at carbon number 1, 2, 3. If you number this way, 1, 2, 3. You see that if I go this way, from right to left, the chloro group, which is a substituent group. A substituent group is an atom or group of atoms that replaces hydrogen in organic structure. This person is supposed to be propane. This place is supposed to be position of hydrogen. But that hydrogen position has been taken by chlorine. It means hydrogen has been removed and its position has been taken by chlorine. So chlorine here is called a substituent group. Atom or group of atoms that replaces hydrogen in organic structure is a substituent group. So that chloro group there is a substituent group. What is the implication? There is a covalent bond existing between this chlorine and this carbon. I taught you that anywhere you see a covalent bond, electrons have been shared to form that bond. Every covalent bond is characterized by presence of 2 electrons. So expect that there are 2 electrons inside this bond. Carbon is a member of group 2. Chlorine a member of group 7, a halogen. Chlorine is highly electronegative. Carbon, poorly electronegative. Meaning that chlorine has a higher power to attract electrons compared to carbon. So what happens? When chlorine and carbon share electrons to form this bond, chlorine is expected to receive a fair share of those electrons. The chemistry language, organic chemo, Chem 122 second semester, is saying that this chlorine will shift the electron density towards itself to develop a partial negative character. When you gain an electron, you become negative. Because you don't have outright gain of that electron, you develop a partial negative character, leaving this carbon here with a partial positive character. And as soon as this carbon number 3, or carbon number 1 rather, because I'm moving this way, this is 1 chloropropane. The chloro group is in carbon number 1. I have to follow the route that gives the substituent group the lowest possible number. If I go like this, chlorine is in position 1. But if I move the other way, chlorine is in position 3. The rule says follow the route that gives the substituent group the lowest possible number. So this chlorine is taken to be in position 1, not 3. And that is why I will call this 1 chloro, meaning that there's a chloro group in position 1. 1 chloro prop. 1, 2, 3. There are 3 carbon atoms. So the parent name will start with prop. And I will end it with aim. Aim because The atoms we have here are linked by single sigma covalent bond. We are coming to that. Single sigma covalent bond. So this is one chloropropane. One chloropropane. One chloropropane. Let's progress. Chlorine here is more electronegative than carbon and receives a phase share. Those electrons have been shared to form this bond. It will shift the electron density towards itself to develop a partial negative character, leaving this carbon with a partial positive character. Once this carbon 1 develops a partial positive character, it will shift the electron density. Remember, the electrons are negatively charged. So the electrons that we see between carbon 2 and 1 will be shifted towards carbon 1, making carbon 2 also to develop a partial positive character. When carbon 2 develops a partial positive character, these electrons in this bond will move towards carbon 2 to leave carbon 3 with positive character, partial positive character. Class, what the implication? Along the chain of this organic compound, there is electron displacement initiated by a highly electronegative terminal, the chloro group. May I announce to you that this electron displacement along the chain of an organic compound is what we call inductive effect. So what is inductive effect in this case? Electron displacement along the chain of an organic compound initiated electronegative group. Electron displacement, you can see how electrons are being displaced towards the electronegative terminal. That electron displacement along the chain of an organic compound is what we call inductive effect. In this course, this second semester, we are going to discuss our next tutorial online here the applications of inductive effect. Reason: inductive effect determines stability of molecules. Compounds. It determines reactivity. They will give you two compounds and say which one is more reactive, which one is more stable. It determines reactivity. It determines stability. For acids and bases, it also determines the acid strength and the basic strength. So there are so many things we'll be discussing under the applications of inductive effect. For now, the assimilating and digesting that inductive effect simply means the electron displacement along the chain of an organic compound, usually initiated by the presence of a highly electronegative